Hey guys, in the previous video lesson we understood the basics of transformations. In this video lesson we would understand how to describe transformations using examples. So here we would do the application of those transformations that we understood in the previous video lesson. Let's take this up with the following example. Let's say we're supposed to describe transformations for this transformed function equation. We see that this whole bracket has a power 2. That means the parent function of this transformed equation is y is equal to x squared, or we can write it as fx is equal to x squared, which is a quadratic function. Now if we write down the general transformed equation, this is how a general transformed equation for a quadratic function looks like. We would just match our question equation with the general equation and then we would read our parameters. So we can see a is equal to 3, k is equal to 2, d is equal to 1, and c is equal to -4. Make sure to take your signs with the numbers as well. Now all we have to do is just describe these parameters. We know if a is greater than 1, it is a vertical stretch by a factor of a, and here a value is 3. K is equal to 2 means it's a horizontal compression by a factor of, because it's supposed to be 1 over k, so it becomes 1 over 2 in this case. D is equal to 1 means it's a horizontal translation, and this is +1 by 1 unit right. Positive means right. And C is -4 means it's a vertical translation by 4 units down. So whenever we are describing transformations on any equation, we always write on the general form of transformed equation, and then we just match our each parameter with the position of the numbers on the equation given. Then we write on the parameters and then we describe the parameters according to the effects. And we have covered up all these effects in the previous video. Those who have not watched the previous video, that was lesson number 3, understanding transformations, they can go over that lesson first and then do these examples. Let's take up another example for the sake of practice. Let's say we're given the equation as y is equal to -square root of 2x plus 1 minus 1. Let's describe the parent function first. We can see that our x is square rooted, along with that this k and this d is also square rooted. So the parent function is y equal to square root x. We can write it as a function equation. Fx is equal to square root x. Now we write on the general transformed equation, y is equal to square root k x minus d plus c, and then all we have to do is just match our a, k, d, c parameters with the numbers given in the equation. So a is equal to negative, no number means it's 1, and a is exactly equal to the value 1, so there is no vertical stretch or compression, but there is just reflection. So the graph is going to be reflected over x-axis. When we say graph is going to be reflected over x-axis, which graph is going to be reflected over x-axis? That's the parent function graph is going to be reflected over x-axis. So if our parent function graph looks like this, the transformed graph will look like this. Talk more about graphing in the next video lesson. Let's first continue this one. Now we see k is equal to 2. We describe the value of k. If k value is greater than 1, that means it's a horizontal compression by a factor of 1 by k. In this case, 1 by k is 1 by 2. Next we see is, because I told you I have to take the sign as well, the general parent function has a negative sign in between x and d, but your question has a positive sign in between x and d. So this means that this should have been like this, x minus -1. That's why we got minus and minus equal to plus. So from here we would pick up our d value, and d is equal to -1. D negative means the graph is, or the parent function graph is, horizontally translated 1 unit left. Next we pick the c value, and c is equal to -1. So the parent function graph is vertically translated 1 unit down. And this is how we describe transformations. Let's do another question. If we have y is equal to -3 minus 2x plus 4 plus 2, our transformed general equation is a k x minus d plus c. Now we would notice one thing, that k has to be factored out of x minus d in a bracket, but here k has not been factored out. So what are we going to do is we're going to rewrite this equation such that k is factored out of x minus d. And how does that look like? The equation is going to become y equal to -3. We're going to factor -2 out, the whole k value that we see in front of x. And we are left with x from the first term. To find out the second term, we have to just divide the second term with the factor that has been taken out. So 4 divided by -2 is a -2 plus 2. If we want to check that our factor or this step is correct, what we can do is we can just use FOIL method. So -2 times x is a -2x. And -2 times -2 should give us a +4, and we've got it all correct. So that means our steps are correct and we have rewritten the equation in the correct form. Now let's find our parameters. A is equal to -3. Now A has both negative sign also and it's greater than 1 also. So when we are describing the value of A, we would describe both this and this. We would say the graph of the parent function would be vertically stretched by a factor of 3, and also the graph of the parent function would be reflected over x-axis. So both of these things would happen because of A being -3. One more thing here we forgot to write down was the parent function. We notice here that this bracket has no power. No power means x is 1. So our parent function is x to the power 1, or we can say it's a linear function. Now it's easy for us to figure out what is k. So k is -2. Here also we see that we have both the negative sign and the value of k is 2. So greater than 1 for k value means it's a horizontal compression by a factor of 1/2, and it's a reflection over y-axis as well. Next we find out what is the d value, and we see that the sign here negative and sign here negative is exactly same. So we pick our d value, and the d value is equal to 2. No sign means it's positive, so it's a horizontal translation 2 units. Right. Let's describe the c value now. C is equal to 2. No sign means positive, so it's a vertical translation of 2 units up. Let's do another practice problem. If we have the equation like this, we notice that the equation is y is equal to -2 to the power. So x has been now raised as a power -5. So from here we would determine that our parent function is y is equal to 2 to the power of x, which is an exponential function. Let's write down the general form of transformed exponential function, and this is going to be a 2 to the power of k x minus t plus c, this whole thing in one bracket. Now we notice that we have the value of a. Again, k has not been factored out, so we would rewrite the equation such that k is factored out, and this is how we write it as y is equal to -2, y is equal to -2 to the power of 3 is factored out of x and 2, so we are left with x from the first term. And then to find out the second term, we just have to divide this by this. So 2 divided by 3 is 2/3. We can leave it as a fraction, -5. Now let's match the parameters. So a is equal to negative, no number means 1. It just shows reflection over x-axis. K is equal to 3. That means it's a horizontal compression by a factor of 1/3. Again, we see d here has a minus sign in the general transformed equation, whereas d here has a positive sign. If we want to change this d to a negative, if we want to change this to a general form sign, that is a negative sign, we just rewrite it as minus, and this whole thing will go as -2/3. So the d value is now -2/3. This means the graph is horizontally translated 2/3 units left. And then goes the c value. C is a -5. That means the graph is vertically translated 5 units down. Let's do one last question for the sake of practice. Let's say the equation is given to us as y is equal to -4/2x plus 1. First, we'll describe the parent equation. So the parent function is going to be y is equal to 1/x. That is a reciprocal function. Let's write down the general transformed equation for a reciprocal function. It's a, in the bracket we have 1/k x minus t plus c. Now in order to make this equation look like this equation, we would see that first we need to factor 2 out, because k has been factored out of x and d. And we notice here that a is outside the bracket. So it doesn't matter if a is written on top like this or it is outside the bracket. And we see that c is missing there. So how can we rewrite this equation as? It's going to be y equal to -4, 1/2 is factored out. X is left from the first term. Second term is +1 divided by 2. It's basically 1/2. Whole thing, because we do not have anything for c, so c is a 0. So remember, if d and c are not there, we put them as a 0. However, if a and k are not there, we put it as a 1. So this is an important point to note. because there could be an instance where any of these parameters would be missing. Now we determine that a value is -4. If a is -4, the graph is going to be vertically stretched by a factor of 4 and reflected over x-axis. Next we match k as 2. So if k is 2, graph is horizontally compressed by a factor of 1/2. Then we see d again does not match the signs. So if the signs are not matching for d, we just take the opposite signs. We know that. Till now we are clear with that. So the d value is going to be -1/2. That means graph is horizontally translated 1/2 units left. Let's now find out the c value. C is 0. If c is 0, we do not even have to describe it because the graph is not going to be vertically translated due to any reasons here. And this is how we describe transformations when we are given equations in transformed function form.